You're welcome, sir.
Yes, sir.
Welcome, ma. Okay, I don't know where others are. I want to take all the time and wait again, though I would have loved to do that. But we have limited time. Like Zoom is allowing us to use their platform for a short period of time. And I don't want to spend all the time on this. So I will have to make progress. I really wish people would have joined in now because our time is counting fast. So in the previous session, I was trying to explain something to us about analysis of data. I will make sure I break it down a little. I'm not in a hurry, so I will not put you under pressure and I will not put myself under pressure. Just take note of everything I'm saying one by one. I will explain the steps I'm taking to you. First of all, this window you are looking at, please, somebody is playing background for sound. Now, if you look at this screen, this is called the output viewer. Every statistical analysis work you do will show on this screen. Every operation you carry out will show on this screen. Anything you do, whether you save a file, whether you do anything, this screen is different from where your data is. This is where your data is. Where's that thing? This is where your data is. This one contains the data view and the variable view. The variable view, data view. But everything you do here is being recorded in this screen. This is your output viewer. I usually call it something like the secretary because it takes note of every activity you perform. For instance, look here, you see save out file. I saved my data, it wrote it there. Okay, this person has saved file and it wrote where I saved the file to. I ran the frequencies, it wrote it that I ran a frequency. The benefit of this is that you can save this document so that you have a trail of everything you did with your data, all the analysis you carried out, everything. You'll be able to have a trail of it, a trail, T-R-A-I-L. I call it data analysis trail. So in case you want to know the steps you have carried out in the analysis of your data, you can always come back and refer to this document. So it is a good thing to have this. That is number one. What's this? Skip. It is a good thing to have this. So how do you go about this? Now, if you want to go to your data, please remember I'm taking you through it step by step. So I will explain so many principles to you as you are progressing. There are tips and tricks as well. If you want to go to your data set straight away, instead of minimizing this screen and just jump in, just look at this red star. It will take you to your data. See, it is called go to data. Just tap on it. From you are inside your data already. But there's no way back into your output viewer. You have to go through either through window, then click on this, or you have to go through your start menu. I can also go from window to my data here. That's number one. Number two is that the last analysis you carried out, You can always use it, find it from this record dialog block. See this one that has 2 bars and a down arrow. If you tap on it, the last few, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The last 12 operations you carried out will show here. So you can see the kind of analysis I've been doing in the past few days, hours, weeks, or etc. What we did last was frequencies. That's why it is frequencies here. But for your sakes, I will be using this one now, use analyze, so you understand whichever one you want to use at any point in time. The data you have in your analysis can be descriptive, categorical, or continuous, or it is also called grouped or ungrouped. So we are doing descriptive statistics. Should I do it this way? No, don't let me do it this way. We have ungrouped data. We want to count how many people were married or not. And this is how we did it. We come to analyze, descriptive statistics, frequencies. So you see then you choose marital status, click on it, use this arrow to take it to the right, or you can use drag and drop. I'm using the drag and drop now. Click on it and drag it to the right. Once you do that, it is here already. Then just press the OK button. Once you press the OK button, you will have the result here. But something is wrong with the result I returned here. What is it? Look here, we have missing system. What is causing this missing system to show in our data? Let us check. The variable we are working with is called marital status. Look, there's an empty cell here. Why do we have an empty cell? It means that probably when the data was being entered, somebody forgot to enter the marital status for this particular person in question. Or maybe the person did not return their own marital status. So in this kind of situation, we have to decide, what do we want to do with this missing data? For now, I'll just treat it as if the person did not respond. I'll change it to decline to respond. Okay, you want to wonder how I did it. Let's go to our coding to know the code we are using for decline to respond. Variable view, marital status, click on it, then click on this blue tick. Decline to respond is called 9. So I'll come here, I'll enter 9. Then I'll press the tab button. You see, I'm seeing decline to respond. So if I run the frequencies again, I'm expecting to not see a missing. Descriptive statistic frequencies, it is still there, it has not gone.
I think it's diverse.
That missing that I had originally has disappeared from the screen. That missing, this missing has been taken care of, it's no longer here. So we have 35 and 54 single, 94 married. Sir. Yes, sir.
On my own screen, I have divorced at that place where we have missing.
Okay, so that means the person is likely divorced instead of missing. So let's change it to divorced. What is the code for divorce? Sorry, I'm using this crude method. There's a faster way to do this, but you have to know the long route first in case the shortcut is not working. Divorce is 3, cancel. So I'll change this to 3. Press tab. So we have divorced. I'll run the frequencies again. This time around, instead of going through this analyze, etc., I'll just pick it from here. Frequencies, the marital status here, press OK. So we have single, married, divorced. And to edit this table, I can right click and choose edit content in viewer or in separate window. I want to do it in viewer. So it is ready for editing. Right click on this to ungroup, then highlight all this, press delete, click outside the table, right click the table, copy it, go to Word or any software you want to use for reporting your result. I'll delete all this, I don't need it now. Paste your table, then give the table a name, table 2. Marital status of respondents, or distribution of respondents by marital status. So then if I want to take this table to the center, please note how I'm going to do it. You see this handle at the top of the table. Once I click on it, I just go and click on center alignment. That has put my table in the center. Because it's not good when you are presenting your result, it's also good for you to think about aesthetics, how to make whatever you are doing to look fine. So I've clicked on the center, the table is in the center. I can now start reporting and say table 2 shows that 54, 35.5% of the respondents were single, 94, 61.8% were married, 0.7% was divorced, and 2.0% did not declined to indicate their marital status. Please remember why I said we are using decline to respond. When I was talking about missing values, I explained that many research, they don't want to see no response. Be like, what do you mean by no response? How can somebody not just respond? So that's why I decided that I'll be using declined to respond. That is to say, the person did not respond. This person say he's not going to tell me their marital status. That one is allowed in research. Based on research ethics, everybody has the right to decline to participate in your research. So, but this is an escape route. But try and make sure that people fill your data properly so that you will not have missing data. Let's look at our questionnaire. The next item is ethnicity. How many people are Yoruba? How many people are Igbo, Hausa, and others? So we go to the questionnaire again, analyze descriptive statistics, frequencies. I'll remove marital status, I'll put ethnicity, I'll press the OK button. So this is it. I will edit this table again, right click, edit content in viewer, or I can just double click on the table, double click, right click on group, highlight these two, delete. So I have my table, I'll just copy it and take it to the Word document, and then have table 3, distribution of respondents by marital status. Paste the table, click on the handle to take it to the center, then write table 3 shows that 125, 82.2% of the respondents were Yoruba, 10, 6.6% were Igbo, 5, 3.3% were Hausa, and 12, 7.9% belonged to other ethnic groups. Full stop. So I've done the third one. What else do we have? The religion. So this is the process you carry out to report each of all these variables one by one, reporting them one by one. But you can also do everything at once. Just go to analyze the statistical frequencies. Just carry out, click on all the variables you want to group. You want to report their frequencies at once, starting with age, drag and drop this time around, marital status, ethnicity. Somebody is putting me on echo. Religion, occupation, highest level of education, and I'll press OK. You see, all the tables are produced at once instead of me doing it one by one. So I can just edit them individually and take them out. I've done age, marital status, ethnicity. So religion, double click on it or right click and choose edit content. I'll double click on group. I like this to delete. Right click, copy, go to Word. That'll be table 4. Table 4. Table 4. Distribution of respondents by religion. Paste. Okay, my table has cut, so I don't want it. Control enter to jump to the next page. So I'll center it. Table 4 shows that 27.0% of the respondents were Christian, Roman Catholic, 48.7% were Islamic, and 24.3% practiced traditional religion. Full stop. So I will just follow that process to report each of all these items. That's practically how everything in the whole of this questionnaire is going to be reported. 1 1 1 1 1 1 1. Let me show you a sample analysis result. Let me see which one. Let me look for my MSc analysis. My MSc, where is it? Where is it? Workplace development and behavior, chapter 4. So look at it here. This chapter presents analysis of data got from the study. I will explain how I did this later. Instead of doing the tables one by one, I merged them together into a single table. Gender, age, marital status. So this is the frequency percentage. Then I wrote the result from the table shows that most of the respondents were female. Age, instead of writing one by one, I just picked the majority. Next, religiosity, which was my second variable. I will explain how I did this later. And then I put some charts. And this is it. So this is the simple thing about analysis. So once you have your data, you can just go ahead and start turning out the results by running the frequency of your variables one by one. Remember that, how do I take this? How do I take this? Okay, let me take you one step further. If you come to analyze, let me remove all this. Just press reset. Everything will go. Let me take age. There are other options here that we did not check out the other time. Let us run the frequencies. If you do not check this box, the result will not bring out anything for you. I will explain later. So let's go. We have statistics here. Maybe the variable you are working with, you want to check the quartiles. That's why I always say that you must know statistics for you to run through SPSS, at least have an idea. Otherwise, you will just be seeing results. You don't know what it means. It will become garbage in, garbage out. Percentiles, quartiles, cut points, etc. Maybe you want the measures of central tendency, the mean, median, mode, measures of dispersion, the values, the skewness. Let's try one or two of them. The mean, median, mode, maybe standard deviation, minimum variance, etc. Let me take everything. Continue. Chart. When you are returning your result, you can also get a chart automatically. Can be a bar chart, a pie chart, or a histogram. Normally, the kind of chart you use depends on the kind of data you are working with. So you may want to understand what kind of data you are working with before deciding on which chart you want to choose. For now, I will choose bar chart. Now it is asking, is this chart going to be based on the frequency or the percentages? The frequency are these ones, whether 41, 47, or we are basing on percentage, 27. Percentage will be a good option because it helps to place everything over 100. So I will choose percentages, continue. Format. In this format, there are some things you should pay attention to, but it's not compulsory. I can just leave it the way it is. How do I explain this to you now? In the format, we have several options. I will start from here. This one says ascending values. This also means my values. You know that when we were coding, we were saying in the value labels we had, okay, let me show you. In the value labels, variable view, we had single 1, 2, 3, 4, 9. This is ascending, this is increasing from 1 to 2 to 3 to 4 to 9. If you want it in descending values, format descending values, then it will count like this: 9, 4, 3, 2, 1. That will be descending values. Let's choose descending values. Format. Okay. So you see, it started with new. No. Something is wrong. Okay, it's running frequencies. So see, it's running frequencies at the bottom of your screen. That means that the analysis I'm asking it to do is rather cumbersome for the SPSS software, and it has to take some time to produce a result for us. So let us wait briefly. This does not happen every day. This is a rare occurrence, and I don't know why this is. Sorry, you may be hearing background noise. I have to relocate to where I will get electricity because the laptop I'm using, the power is not very strong. So we have age 30 plus 20 to 29 less than, because this one was coded as 1, 3, 2, 1. That is descending values. Whereas here it was ascending values. 1, 2, 3. Remember, I said it is like this. Where is it? Age. 1, 2, 3. That is ascending count. When I chose descending count, it's taking it 3, 2, 1. That is why the result came out that way. I can rather choose it to be frequencies, format, ascending count instead of ascending values. Okay, let me disable all these ones. They have made my result to take some time. I don't want that. I don't want my work to be delayed. So chart, I don't want a chart. Do I want a chart? Okay, continue. Okay, now you see here we have descending count. This is count. Count means how many people are in each category. It has arranged our result in descending order. So we have 33, 43, 76. Irrespective of whether this thing is aligning and making sense. Normally, your result will be better off with this one in ascending orders. But maybe you want to see which group is lowest or highest. You can run it like this. And if you look at our chart, it was arranged in ascending order. I'm going to invert it now to make it into descending order. So come to analyze frequencies, formats, descending counts. See, this is the highest, second highest, then lowest, descending. The same thing here, it is descending count. So you can format your table in ascending or descending values or ascending or descending counts. This one can be done in any analysis software. I'm just showing you how to do it in SPSS. To get other software, you may need to get their help materials or check on YouTube or just Google it, how to report results in descending count with data, with R, with GraphPad, anything you can think of. So frequencies. So I want it to be descending, ascending values. Now here we have compare variables or organize output by variables. When I say organize output by variables, each of these one will stand on a table of its own. Let me show you now. Sorry. This thing works better when you are splitting your data. And I think we talked about splitting data, but if we didn't, I will come back to it to talk about it later, about splitting your data, splitting your result into groups. I think I'll talk about it later. I may get into it, I may not. So now you remember that when I wanted to run the frequency earlier, I chose some statistical tools. I'll do that again now. Then I will explain some things to you from there. And I will take a short break to ask for whosoever will have questions. Then we proceed. See, now let us look at this table together. We have n, valid n, missing, there's no missing data. The mean is 1.93, median, standard error of the mean 0.57, median 2, mode 2, standard deviation 0.76, variance. You see all these figures that we have here, they are meaningless. I will explain. This is the mean of the count. You know, we coded it as 1 for group 1. This is 2, 3. It's now telling us that the mean is 1.93. You can't have a mean for a categorical variable. Maybe, for instance, if this thing was gender, it's not less that the mean gender was, let me do for gender and religion, so that to make some sense, better sense. Okay, marital status and religion. So for marital status, no. Formats. For marital status, the mean marital status was 1.79 and the mean religion was 1.97. What does it mean if you have the mean marital status? It doesn't make any sense. It doesn't make any sense. You cannot have the mean marital status. You can only have the mode, which is group 2. Let's check. Group 2 is the mode. Here, group 2 is the mode as well. We cannot have standard deviation of a group data. What is standard deviation? So these figures are meaningless. But assuming we are working with on group data, for instance, the age, the income, then the mean and the median will make sense. I will show you that now in a few minutes, in a few seconds from here. Now look here, we have the bar chart. Let me show you now, analyze. If you look at our data, I'm sorry, I know that what I'm saying may be boring. Am I making sense? Please let somebody say something. Hello? Am I making sense in what I'm saying?
Yes, sir.
Yes, you are.
Yes, you are.
Are you able to follow? Is it clear?
It is.
Okay. I want to be sure because I know that what I'm saying may sound like Chinese. Now, we have been talking about grouped and ungrouped data. The way you run descriptive statistics for group and ungrouped data are different. Look at the age here. Originally, when we were collecting data, we collected the age data as ungrouped. But we want to show, because the variable is going to be large and the report will be meaningless, we decided to group the age, and we were reporting the age as grouped, where we can easily see, okay, in chunks, how many people are in category 1, category 2. But if we want to look at what is the distribution of this ungrouped age, then the mean will make sense, the median will make sense, the standard deviation will make sense. So we come to analyze frequencies. So I'm going to press, hey, I'm running out of time. I have less than 10 minutes. Thank you, Zoom. I'm going to press reset to remove everything from here. So I'm taking my age in years now. If I press OK, you see, valid, then I have a long table. This table is too meaningless. Well, how can we make meaning of this? We can use a histogram to look at how the age is distributed. So analyze, chart, histogram, and I'm including the normal curve. Continue. Okay. Now we have this table, then we have this. See, now let us look at this table. This is 15 years old, this is 35. The table does not show a particular pattern of age distribution, because it looks like this line is called a normal curve. You need to read about what a normal curve is, and then how we use it in statistical research, that you can be able to make sense of why this data is normally distributed. Once this thing takes a bell shape, and you see that these 2 points are fairly touching the ground, then it shows that data is normally distributed. It can be skewed to the right or skewed to the left. Then this tail will be longer than this one, but it's not. Then when you hear something like one tail or two tail, this is two tail, this is tail 1, tail 2, and the rest, and etc. like that. So this is one way to look at our data. We see that it's normally distributed. Then we can now get the mean. Let's look at statistics. Now let's check all this. So I'll run the skewness, the kurtosis, cut points. Then if you want the 25 percentile, 58 percentile, continue. Okay, now let's look at it this time around. The mean age is 23. This one is making sense. That means that on the average, the respondents were 23 years old on the average. If you want to look at it, that means that they are like in their 20s. The standard error of the mean is 0.447. The median age is 24. That means that if you arrange the data from top to bottom, in the middle you find the 24-year-old person. Then the mode is 16, which is an issue actually in statistics. We have the standard deviation. Standard deviation is talking about how spread out your data is. If we add this 5 to 23, we have 28 at the upper extreme. And if we deduct this 5 from 23, we have 18 at the lower extreme. So our data kind of ranges between 18 and 28. Like most of the data is around 18 and 28. Then you can have extreme values. I will confirm that to you now. The variance, which is the square of this standard deviation. Standard deviation is square root of variance. The skewness, standard error of skewness, kurtosis, range is this one minus this one, minimum minus maximum. The sum of all their ages. Then these are the percentiles, 10 percentiles, 38, 58 is the median. This is the median, and this is 58 percentile. So that's why they are equal. That is number one. Now let us examine. Yes, please.
Okay, from this table you just showed, is it possible to know the long table that shows standard deviation and the rest? Is it possible to know if the graph or the histogram is skewed to the right or to the left? I saw something like skewness, and
Yes,
then I
this
have
is it.
0.127 here. Does that mean from this skewness I should be able to know if the something is to the right or to the left, or what is the essence of them writing of each
Nobody
reporting here?
will actually ask you for this in your analysis result. It is not common. And
Okay.
then I'll need to consult my textbook before I answer this question. I'm sorry I did not read it up before coming to
Okay.
class. But you can these two figures can be used to explain this bell shape to tell whether the data is normally distributed or not. But here it's look like this data is skewed because it is greater than 0. It's not supposed to be. Don't take my word for it. I would recommend that you read up on this particular part. It's not supposed to be above 0. If it is 0, that means that the data is not tilted. Then kurtosis is talking about, I think, the whether this thing is too, oh, let me remember, too steep or too flat. The flatness of this curve or the steepness, bóyá ó slope very, bóyá slope ẹ̀ ó bóyá ó pẹlẹbẹ àbó ga sókè. Maybe it is
All
flat or it is steep. Let me just, like a hill. Let's say this is a hill. Is this hill steep or it is flat? You see some curve, it will go like this. It will be like flat near to the base. Or is it too steep? So that's what this kurtosis will tell you.
right. Okay.
And it is negative. So this thing is not perfect, but at least it is all right. If you want to know whether this data is normally distributed, apart from this histogram, you can do what is called a test of normality. In the textbook I shared with everybody on the Telegram page, there's a part that talks about step of, let me just show you now. Let me show you now once and for all. Let me find kurtosis. Yes, this is it. Can you see my screen, please?
Yes.
Okay, thank you. Kurtosis or kurtosis, don't mind me. In addition to skew, we measure kurtosis. This describes the pickedness of the curve. A normal distribution is often referred to as being mesokurtic, which is another reference to the bell shape that we are aiming for. However, we may encounter problems with curves that are too peaked or too flat. Your curve is not supposed to be too peaked or too flat. A leptokurtic distribution describes a curve that is peaked, that is like a pointed heart. Look at this one, it is too peaked. See, it is leptokurtic. And a curve that is too flat is called platykurtic, like this now. But the curve we have is neither leptokurtic nor platykurtic. It is rather mesokurtic. Now let's go to the skewness, skew data. By definition, normal distribution, blah, 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 blah. We call, if there are extreme scores at one end of the distribution, it is likely to skew the mean score away from the median. We call these extreme scores outliers. If the data is skewed, this can distort the mean score and can bias any test that depends on the mean. The data can be possibly skewed. When data are possibly skewed, there are extreme outlier scores at the higher end of the range of data. Possibly skewed, see, the tail is tilted more to this side. Then one tip of the curve points towards the right hand side. The mean is drawn to the right and it is higher than the median. If it is negatively skewed, the mean is lower than the median. Let's look at our data. Our mean is lower than the median, so it is negatively skewed, but it is very, very slight. You see, this is just 0.1 point. So that's why the data can still pass for a normally distributed. It's just very minute, it's not easy to point out. There's something else about this that I want to look for. What happens when data is not normally distributed? Let me see. There's something I'm looking for. I want to use it to explain the skewness. Box plot. I'm not talking about box plot. I'm not talking about this stem and leaf. I want to check the skew and the kurtosis, Komogorov's, Smirnov. Okay. Okay, kurtosis, skew is of a data is in terms of whether it's positive or negative. Data that are potentially negatively skewed will be indicated with a minus sign. You remember I said that negative skewness means that the mean is higher. Hey, our time is up. Let me just stop now. Don't let me speak. I have less than a minute. I don't want Zoom to lock us out before I finish saying what I'm saying. So let's take a 5 minutes break. Then I'll come back and explain skewness. No, it may be less than 5 minutes once the video finish converting. So please let us just exit the class. And I don't want it to end for us before I finish talking. I may be cut off midway. So I'll be back shortly. Thank you.